Okay. So I need your attention up here, please. We're going to go over pyramids first. As you saw with prisms and cylinders, the surface area formula was actually the same. I know we talked about it slightly differently with the cylinders because of the base being a circle, but that surface area formula was the same. It was the lateral area multiplied, or lateral area plus 2 times the area of the base because there were 2 bases. Pyramids and cones only have 1 base, and their surface area formulas are the same. But again, with cones, you're going to see the base is a circle, so you can write the formula differently. I'm going to kind of treat it as using the same formula so you don't think of having all of these different formulas. Really, between 12.2 and 12.3, there's 2 formulas for surface area, even though they can be written differently. So pyramids, to start out, a pyramid is a solid with 1 base. You can already start to think about how the surface area formula is going to be different. You're not multiplying the area of a base by 2 because there's only going to be 1 base. The lateral faces of a pyramid intersect at the vertex. So if you look at that picture of the vertex below, you see the base. This very top point is what's called the vertex. That's what we're referring to. The altitude is the segment from the vertex that is perpendicular to the base. Perpendicular being the key. Remember, altitude or height always has to be perpendicular. So on the diagram, they label it the height, but if you want to put next to that, that is the altitude. The height is just the length of that segment. And then we have pyramids, and then we have regular pyramids. So a regular pyramid, those have a base that is a regular polygon. What does it mean again when you say regular polygon? What does regular mean? So what's special about a regular polygon? Isaac? Yep, all the sides are congruent, so that's important. The ones that you're going to be working with, I'm pretty sure in our examples and on the assignment, they are all regular polygons. You can assume they are regular polygons, the bases, unless it'll tell you if it's not. It would be labeled so you know that it's not a regular polygon. So a regular pyramid, the base is a regular polygon, and the altitude has an endpoint at the center of the base. All of the lateral edges are therefore congruent. So if you want to actually write the word in, or you can just put the congruent symbol. And then all of the lateral faces are congruent isosceles triangles. So again, if it's regular, it shows here a lateral edge. Those would all be congruent. So if you just look at one of your lateral faces, it's a triangle. If both sides are congruent, then it is an isosceles triangle. And then something that we did not talk about with, or it didn't apply to prisms and cylinders, the height of each lateral face. So that is this right here. It's not the height of the actual pyramid. It's the height of the isosceles triangle. That is called the slant height. So the height of each lateral face, again, that means the height of each triangle. So not the height of the actual pyramid. And that slant height is important. Slant height, I'm not sure why, but they use L to represent the slant height. And if it helps, draw it in as like a cursive L so that you don't confuse it with a 1 or a capital I or something like that. But then you can see this is our formula for the lateral area of a pyramid. So the lateral area is equal to 1/2 times. P still represents the perimeter of a base. So if you wanted to write that in, perimeter of base. And then L is your slant height. So that slant height is important. You need it to find the lateral area, and you need the lateral area to find the surface area. To help explain this formula a little bit, because with prisms and cylinders, it was just the perimeter of the base times the height of the actual solid or actual figure. So if you're finding the areas of all of these triangles, each triangle has an area of 1/2 times the base times the height. So if these are all, or with all of these triangles, their slant heights would all be the same. And then each of them has the same base, and if you add all of their bases together, you get the perimeter of the base of your pyramid. So that's why it's 1/2 times the base of the pyramid times the slant height. That really is each of those 4 triangles, or however many you have, all added together, those areas. But that's a shorter, more simplified way to get it. And then here's your surface area formula for a pyramid. You do not have to memorize these surface area formulas, by the way. You do have to know what all the letters in the formulas represent, but that formula will be given. It's on your review, it'll be on your quiz, it'll be on your test. So you do have to be able to identify, like if I ask you to find the area or find the surface area of a pyramid, which formula you're supposed to use, and then you have to know how to find everything in it, but it's given to you. So we have the 1/2 times the perimeter of the base times the slant height. That's your lateral area, plus there's only one base, so plus the area of your base is the surface area. So again, P is the perimeter of a base, and then capital B is the area of the base. And L is your slant height, not the actual height of the pyramid. That's a big difference from prisms and cylinders. So the first 2 examples are just having you find either the slant height if the actual height or altitude is given, or vice versa, if you're given the altitude to find the slant height. So if we look at example A, so the slant height, I know this, the way it's shaded and then copied, it's hard to see, but you could actually draw in like the height of this triangle. Not sure how well you can see that, probably can't see it at all. So I'm just drawing in that slant height. You could draw it in a different face too. And then you see that the actual altitude, the height of the pyramid is already drawn in, that's 12. So the actual height and the slant height together, if you connect them, they create a right triangle. And that means you can use Pythagorean theorem to find it. So actually, because it's kind of hard to see, I'm going to draw the right triangle that's in there off to the side here. This is what we have. We know this is 12. This is our slant height that we're going to be looking for. So I'm going to label that L. And then if I know that the side length of my base is 10, and I can see this is an actual square, it's 10 by 10, then the altitude, this length, is half of the length of the base. So this would be 5. And then I can use Pythagorean theorem to find L. So I would have 12 squared plus 5 squared equals L squared. I'm just going to do 12 squared and 5 squared right away, and adding those together, that's 169. Yep, take the square root. And the slant height is 13. And so you might have to do that for a problem. If you are not given the slant height and you have to find the surface area, slant height is part of that formula. You have to do Pythagorean theorem to find that. Or special right triangles, or other things might work too. So then for the second one, we are given the slant height. So that is labeled here, that's and those units are inches. I know it's written very small. So if you were to draw in the altitude and kind of connect it so you have your right triangle there. So we are looking for the actual height. I'm going to label that H. So I now have my hypotenuse is 10. What is the other leg of my triangle? How long is this? 6. Yep, it's going to be half of the 12. So then Pythagorean theorem again, I would have h squared plus 6 squared equals 10 squared. So that is h squared plus 36 equals 100. Subtract the 36. H squared is 64. Square root it, and your height is 8. Okay, so make sure you not only know the difference between the height and the slant height, but that you know how to find each, depending on what you're given. Any questions on that part? Okay. Brevin and Tommy, are you with us over there? Okay, why don't you put the phone away? So 1 and 2 then, these examples, finding the actual surface area before we go on to cones. So usually how I label this are the 3 pieces of the formula that I actually need to find the surface area. I need the perimeter of the base, I need the slant height, and I need the area of the base. So I need to know what is P, what is L, and then what is B. And once I know those 3 values, then I can find my surface area. Perimeter of the base, and again, you're assuming that you have a regular pyramid, meaning your base is a regular polygon. It will tell you if it's not. So I can assume that all of these sides are 14. So the perimeter of my base would be 14 times 4, so 56. I do not know the slant height. I know the actual height is 12. Slant height I am not given. So I need to find that. I'm going to draw that in. So this is L. Draw my right triangle here. So I know the height is actually 12. I know this side of my right triangle would be half of 14, so 7. So I would have 12 squared plus 7 squared equals L squared. And 12 squared plus 7 squared is 193. So now I've talked about this before, that normally what I really try to do is not round until the end. If you are rounding in the middle, as long as I see where you're getting your values from, it's okay. Just make sure, like I said, I can see where you're getting your values. And then as long as all your work is shown there, it's okay. So if I take the square root of 193, I'm going to get a decimal. It's not a perfect square. So right now, I'm just going to leave this as L is the square root of 193. And I'm going to substitute, when I put these values into my formula, I'm going to plug this in so I'm not rounding my answer until the very end. And then I need the area of the base, which it's a square, so that would be length times width, 14 times 14, or 14 squared. That's 196. So my surface area is, and again, the formula is up here. So you can see where I'm getting this from. So I have 1/2 times, perimeter is 56, times my slant height is square root of 193, plus, and I only have one base, so 196. And then I type all of this in. And again, I know calculators work differently depending on which one you have, so make sure you can type it into yours and get the right answer. So I usually, the way I type this in, I type in 1/2 is 0.5. So I would do 0.5 times 56 times the square root of 193. Make sure you close the parentheses. And then you could hit enter here. Actually, I will, because if you were just asked for the lateral area, that would be it. And then I would add to that 196. So my surface area is about 584.99 or 585.0 if you're rounding to one decimal place. Normally, we've been rounding to the nearest tenth, so I'll do 585.0, and that's feet squared. Okay, any questions on that one? Okay, the second one. This one is a little bit different because it gives you this 60-degree angle there. So to find the surface area, again, I need the perimeter of my base, I need my slant height, and I need the area of my base. But the only thing I'm given is that the height is 10, and then I know this is 60. So to actually find the perimeter of my base, I can find this side of my triangle. This is a special right triangle. This would be a 30-degree angle up here. So I'm just going to draw out up here my special right triangle, which if you need this too for a quiz or test, it would be provided to you. So I know this is 10. Or actually, I don't want to put the number there. Sorry, I was going to put the formula. So again, the formula is opposite of 30-degree. That's your short side. I'm going to call that x. And then your long side is x times the square root of 3. And then your hypotenuse is 2 times your short side, so 2 times x. So this one, because of the square roots in there, I'm going to make an exception. I am going to round in the middle here. You'll see why. So if I need to find the short side, because right now I have the long side is 10. So the 10 is equal to the short side times the square root of 3. So I'm going to set up an equation. I know I'll do this over here. X times the square root of 3 is equal to 10. Because then I need x, I need my short side to get this side and my hypotenuse. So I would divide by the square root of 3. So this is where I'm making the exception. I am going to round this. So 10 divided by the square root of 3 is 5.77. So this one I am going to keep to 2 decimal places. My final answer I'm going to round to 1. So I'm going to round this one a little more than that so it helps my rounding in the end. So then if I know this is 5.77, then I know my hypotenuse, which is my slant height, is 2 times as long as that. So if I multiply that by 2, I get 11.55. I had multiplied the exact by 2. So if you actually typed this in, you'd probably have 11.54. But 11.55. So that's my slant height. That's actually also the length of one side of my base because this is only half of it. So then I can find my perimeter by multiplying that by 4. So if I do times 4, my perimeter then would be about 46.19. And now I just need the area of my base. So now if I have to go back and type in 11.55 squared or times itself. This would be about 133.40. And now I can substitute this all in. So my surface area is 1/2 times my perimeter, 46.19, times my slant height, 11.55, plus The area of my one base is 133.40. So 0.5 times 46.19 times 11.55. So if you were just asked again for lateral area, that would be the lateral area, and then plus 133.4. My surface area is approximately 400 this one I'll round to 1 decimal place, so 400.1, and that would be centimeters squared. Okay, so clearly, hopefully you've seen not only, or before today, with prisms and cylinders, there's a lot of pieces that go into surface area. So it's very important that you're showing how you're getting everything. Questions on pyramids? This, I think, was the toughest because of the special right triangle in there. Then for cones, we just at least need to get, I want to get through at least one cone example here. Because there isn't a special right triangle with this one. So a cone has a base in the shape of a circle. So this is kind of like how we did prisms and then cylinders, and cylinders just seemed a little different because you had circles for your bases. This is that same thing. Pyramids and cones are similar, but then cones have a circle as their base always. So cones have an axis. The axis of the cone is the segment with endpoints at the vertex and the center of the base, which the base is the circle. And if the axis is also the altitude, the cone is a right cone, which in our examples, you can always assume it's a right cone unless it tells you otherwise. If not, if the axis is not an altitude, the cone is an oblique cone. And then it shows that difference. So if the cone is kind of slanted a little bit, like it shows here, it's oblique. Otherwise, it's a right cone if the axis is also the altitude. Notice these also have a slant height. So the altitude, the actual height, is different from the slant height. This we also label L. Here's the formula for the lateral area, although actually I'm not going to highlight that because I want to kind of keep or limit the number of formulas you have. So here's the surface area of a cone. It's written differently, but it says or. This is the exact same formula we just saw for pyramids, and it still applies to cones. P is the perimeter of the base, which the perimeter of a circle is the circumference. So this here, the 1/2 P times L, that is your lateral area. So that's a separate formula, or that's, I guess, it's equivalent. I know it looks very different, but that is an equivalent formula to get the lateral area. And then B is the area of a base. So if you kind of compare these formulas, think about it this way. 1/2 times the perimeter times the slant height. Perimeter for a circle is the circumference. So if I take 1/2 and I multiply by the circumference is 2 pi r. Notice the 1/2 and the 2 cancel out, and that is why pi times r times L is a formula for the lateral area. So that's why they have it written that way. Rather than using a bunch of different formulas, this is the formula you're going to be given on your quiz. I would just use this one or practice using it this way and not try to separate a cone formula from a pyramid formula because they are the same. It's just you can simplify it or rewrite it when it's a cone. And then you have your area of your base. Area of a circle is pi r squared. So you could write it that way. That's why they have it written differently. So actually, I'm going to skip over this example because we have to find the slant height for this example anyway. So we're going to do that in this example. And the way you find the slant height for a cone is the same we did for a pyramid. So if we want to find the surface area of this cone here in number 3, right now I have the actual height and then I have the radius of my base. So this right here is my slant height. And so I'm going to write down the same things I wrote down for pyramids. I need the perimeter of my base, I need the slant height, and I need the area of my base. Okay, so I'm going to treat this just like I did pyramids. I'm not going to think of it as a different type of problem. Perimeter of my base is the circumference. So that would be 2 times pi times the radius. So 2 times pi times 9. And again, trying to keep things exact until the very end, I'm going to multiply the 2 and the 9 to get 18. So this is 18 pi. I'm just going to leave it as 18 pi. To get my slant height, I need to use Pythagorean theorem. So 12 squared plus 9 squared equals L squared. And 12 squared plus 9 squared is 225. That is a perfect square. If I take the square root, L is 15. And then the area of my base is the area of the circle, so pi r squared. So pi times 9 squared. And again, I'm going to keep it exact, so 9 squared is 81, so 81 pi. So my surface area is, again, going off of this formula that I highlighted, the one we were using for pyramids, so 1/2 times perimeter of the base is 18 pi times slant height L is 15. So if I just multiply those, that's my lateral area plus area of my base is 81 pi. So I type this in. So 0.5 times 18 pi times 15. So if I just asked you for lateral area, that would be your answer for lateral area. And then plus 81 pi. That gives me the surface area. So 678.6. And that would be in centimeters squared. Okay, any questions on that one? Okay, we have about 4 minutes. I'm going to pass out your assignment, but you have enough time, I think, to actually answer number 4. So practice one of these on your own. See if you can find the surface area for example number 4 while I'm passing out your assignments. I will show the answers so you can check it.
Yeah, I do. I bet you have been I'll pay you to do
All right, and then when you are done, so I'm going to show the answer up here. When you're done, you can check it. And then let me know if you have any questions before you go.